And you can do that with loops. The interesting thing about loops is repeating stuff is pretty darn easy. Just like skiing, though, stopping is the hard part. Looping is easy, stopping is hard. The first basic loop, the first basic way of repeating a bunch of code that you want to look at is a while loop. And a while loop start with an if statement. You can say their ancestor is an if statement. You might look at if a variable a is equal to 1, or you set it equal to 1, then you test if a is less than 10, do some code. And you could do this over and over and over again manually, one at a time. But it's quite tedious and prone to error and hard to debug. So we have come and replaced the if keyword with the while keyword. So while a is less than 10, do some code. All we did was change if to while, and now we have a repeating loop. If you're noticing something is a little bit amiss in that a is always going to be less than 10. We have basically an endless loop. We have a loop that will never end, and it's not a good thing for loops never to end. So how do we stop this? We take within the loop, every time it loops around, and we add 1 to this variable a. Now if you look at this, there's some naming conventions to it. This variable a is commonly known as a counter, and it counts the number of times through a loop. We've taken variable a and set it equal to 1 before we go into the loop. We're testing it. We're testing a condition, is a less than 10? And if it is, it's going to run through the code. It's going to add 1 to a is a plus 1. That's one of the shortcuts for the numeric operators, if you recall. Then at the end of the code, it goes back and tests the condition. While a is less than 10, add 1, and it keeps adding and adding and adding until it goes through about 10 times. Then at some point, a will be greater than 10, and it will stop and kick out of the loop. Now, a do-while loop is exactly the same as a while loop, except instead of testing for the condition at the beginning, you test at the end, which means, interestingly enough, that the code is always run once. So you start with the keyword do, put your code block between curly braces as always, and you add the while statement at the end. And since it is a statement, you do have to put a semicolon at the end. In all honesty, I don't use do-while loops nearly as often as you use while loops. Maybe one time out of 30 or 40 times, there might be a reason to use a do-while. But generally, while loops are much more common. In fact, they are so common to do this kind of pattern of setting up an index or a counter and then checking the condition of it and then incrementing it that there's a shortcut. Programmers hate to type. We're a lazy bunch and we love our shortcuts. So if you take this while loop, all these different kinds of things that are done often enough, setting it up, checking it, incrementing it, you end up with a for loop. For is the keyword. You set up the index, semicolon, check condition, semicolon, and increment the index. And you can do this all in one nice, neat package that's a great shortcut that's used ever so often. And just get used to it, and because we'll be using this a lot. Notice the curly braces that contain your code. So a for loop starts with a for keyword. You set a variable for the index, the counter, and check the condition and set an index to increment value. If you want to get out of a loop, say you're in a game and it's looping and the score reaches a certain point, you can put in a break command. Notice the break in blue there. And all it does is stops whatever's happening and jumps out of the loop. No matter what's going on, when it hits that break, it jumps out of the loop. A continue statement is very much like a break statement, except it doesn't jump out of the loop. It just stops that iteration and goes back and tests the variable again. So if you've got 20 statements of code, it hits the continue at about 10, it'll skip the last 10 and go back and test the condition again. Where a break point or break command would jump out of the loop, completely jump out of it. Now there's some handy methods that you can work with in some code we're going to look at. You want to keep these guys around, probably put them in your cheat sheets. Remember this number my variable? It was in the book. Any variable you want to test and see if it's a number, or you want to coerce it to a number, excuse me, then you just say number, open close parentheses, and throw what you want to try and convert to a number in there. And if it's possible, it will make it a number. Very handy for processing form values. Not a number, NaN, is not a number, is a verb that tests and says, hey, is this true or is this false? Is this variable a number or not? Is not a number. In other words, is it text? So it always returns true or false. If something is not a number, is a handy thing that we're going to be using a bit. There are some shortcuts, some what are called libraries built into JavaScript. Math is one of them. You have a lot of math functions in JavaScript, and one of them is just rounding numbers. So math.round, and then put your variable that you want to round in there. Rounding is the same as in elementary school math. You take whatever number and round it to the nearest integer. Math.round 0.6 goes to 1. 0.5 goes to 1. 0.49 goes to 0. Think of the number line. You remember the number line? Math round negative 4.4 would go to negative 4. That's the closest number on the number line. And negative 4.6 will go to negative 5. Math.ceiling is interesting because it rounds upwards to the nearest integer. Think of the number line as you're doing this. A ceiling for 0.6 is 1. A ceiling for 0.4 is also 1 because it's rounding up. Math.ceiling rounds up. Think of the number line there as you do this. The complement to math.ceiling is math.floor, and it rounds a number down. Kind of handy at times. If you just want an integer value, it's very handy. Whew. Last big topic for this week are functions. Functions are like robots. And of course, everybody needs a robot, because robots are great for automating tasks. You can tell robots to go fetch the slippers, go wash the car. They obediently obey your command. And to create a robot or a function, because robots in JavaScript are called functions, you use the keyword function to create one of these robots or one of these functions. Makes sense. It seems kind of straightforward. You have to give these functions a name. You occasionally use the parentheses to contain stuff. We'll get to that in just a second. But since functions, by their very nature, are verbs, they have these parentheses that kind of are typical of verbs. And you have some code within the code block denoted by curly braces. So you have a keyword, you have a name, and you have some code. The problem is every function, every robot has to be assembled. You got to make these things up before you can use them. You have to put them together. So let's create a function. We have a function with a keyword, a function. We have a name for it. We're going to make a pizza. We have this option in here in the parentheses called topping, and we'll worry about that in a minute. And you have some statements to make a pizza. So if you created the function, then you can use it. If you've built a robot, then you can use it. So the way to use a function is to use the name and the parentheses, just like it says in number 2. So you create the function, make pizza, run some code. Then to use it, you would call the name, and if you need to, pass it some parameters. Now, just like old number 5 in the movies, you can also give functions input. That's what that parameter was. So you have a function and a function name and a parameter. A parameter is optional values that might get used in the code of the function. And you don't have to have just one optional value or one parameter. You can have a bunch of them, but you always have a keyword, you always have a name, and you can have this optional parameter. Keyword, name, and parameters. Say, for instance, we have a function with a function name, keyword, name, and we have a parameter over here. If you want to get a value back to your code after you run or call a function, you use this keyword return, and you also send in a value. Usually that would be a variable, and like all statements, it ends in a semicolon. So, makes sense when you use it in context. We have this function called Fahrenheit to Celsius. We're going to pass it a temperature in Fahrenheit, and we want to convert it to Celsius. So we name our function, name it Fahrenheit to Celsius. We send in a parameter or an optional value called temperature Fahrenheit. Then inside this function, we declare a variable, temperature Celsius equals, do some math to convert it, and return that temperature Celsius value to wherever the function was called from. What's really cool is anytime you create a function, you can call it anywhere in your program and it runs the same code. You don't have to keep retyping stuff. Use it over and over and over again. Again, the second sample is just very similar. You're using some math to convert Celsius to Fahrenheit. Take a function, a name, parameter, and inside converting that value to Celsius. Excuse me, Celsius to Fahrenheit. And you're returning the Fahrenheit value. So, getting information out of functions, you just use the return keyword and the value. So if we have a variable, name of myTemp, and it equals to, it's being set to the function Fahrenheit to Celsius with a parameter of 80. It's going to pass that 80 to the Fahrenheit to Celsius function up above and return a value of the temperature in Celsius. So you can say my temp is, plus sign is concatenate or mushed together, my temp, which is the variable, and then you also add another string literal onto the end, or you can concatenate it, or you kind of mush it together. Think about that. This is an example pretty straight out of our supplementary textbook. Now note that return keyword should be the last statement in a function, since as soon as a browser's JavaScript interpreter encounters it, it's going to exit that function. Any lines of code following a return statement aren't going to be executed. So a function can only return one value. If you want to return multiple values, store the results in an array and return the array. Arrays are really cool for this. So you could have, to get out of a function, you could have temperature, you're passing to Fahrenheit to Celsius, doing some math, return temperature in Celsius, and you can see down below that we're also rounding up, math.ceiling. So we've got in the middle of the parentheses the 80, which is the temperature we're passing to Fahrenheit to Celsius, which is that function. Then in another set of parentheses, we're telling math.ceiling to round it up.